Mpirical provide compelling, interactive learning across a range of delivery options. Live on site, live online, or online anytime, we have a training course that is ideal for you. For a no-obligations chat about your training requirements, contact us at mpirical.com.
There are many challenges when it comes to 5G radio planning. So to start with, we want to get to 5G. The key thing about 5G is there's a new 5G, what's referred to as new radio air interface. And obviously that goes a long way in getting you effectively the 5G system. However, we still need to plan the network. And that involves looking at where are we going to put 5G, and we have effectively some new radio spectrum to look at, as well as existing spectrum. We've got to think about some of the new techniques and features that come about by utilising some of that spectrum. And that's including massive MIMO and beamforming. We also have so many deployment options. And depending on those deployment options, again, depends on how we might need to plan the network. So to start with, let's introduce some of the key features that we're going to get with the new air interface. So first of all, with 5G, it's a new air interface. There are some new waveforms, and you'll hear the term cyclic prefix OFDM. Now, OFDM, orthogonal frequency division multiplexing, is a generic term, and we use that in other systems such as 4G, Wi-Fi, etc. Here it says CP, cyclic prefix OFDM. A cyclic prefix is something you have in a lot of OFDM-based systems. So this is quite a generic term, but there is a new waveform, and this is what it's called as far as 5G is concerned. Now this new waveform can be used in the downlink direction, but it can also be used in the uplink direction. Now one thing to highlight is there is another what's called optional waveform. So optional implying that the device and the equipment, the base station, might not support it. And that's referred to as discrete Fourier transform spread OFDM. We're not going to go into the details of these, but as you can see, there are new waveforms. Now, what's more important here is the fact that this optional waveform is there, and that's there because what it will do is it will improve the uplink performance. So the key thing there is uplink. So in the downlink, you still have to use cyclic prefix OFDM. However, optionally in the uplink, we could be using this discrete Fourier transform spread OFDM signal. Now that's going to change some of the aspects of radio planning, because obviously it will change therefore the performance of the uplink, and therefore the cell footprint, and therefore how many cell sites we might actually need. So it's worth putting that into the mix effectively when discussing radio planning. Now, I've illustrated here a device which might be an IoT device, a machine-type communications device, which might warrant effectively this optional waveform to be included. But it could be a normal cell phone that needs obviously this feature or has this feature included, which means that when you're inside and having a poor uplink performance, we could optionally use this new waveform to improve that. Again, that's all part of understanding what our devices are capable of doing and how we would plan them. Another key feature of this new air interface is when it comes to the actual channel. As I just mentioned, we're using orthogonal frequency division multiplexing, and what that means is instead of having a channel, in this example, a 100 meg channel, straight away 5G supports bigger bandwidths. The key thing is with OFDM systems, we have something called subcarriers. So rather than using one carrier, we have lots of these little subcarriers. Now, what's quite crucial when it comes to 5G, when compared to 4G, is the fact that the subcarrier spacing in 4G is quite fixed, whereas in 5G, it actually can change. So in 4G, it's usually 15 kilohertz. There are a few tweaks there, but we're not going into the detail. In 5G, you can see I've got 15, 30, 60, 120, 240, etc. And the idea is these different sub-carrier spacings are typically linked to the frequency band of deployment.
Need to know more? Why not visit our store, where you can choose from over 200 hours of video-based training. Alternatively, you can contact us to discuss any specific training requirements you may have.